So it's the integrated 2 trigonometry review for this next essential skill. Things you need to know. You need to know tan and inverse tangent, sine and its inverse, cosine and its inverse, and how to apply trigonometry to a situation. Okay, so let's go through and solve for x, y, and or theta. Since this is basically an interactive worksheet, probably be a good idea to pause the video, do problem 1, come back, check it, and see how you did. I will work through the first one on each one of the following slides. So if we take a look at this one, first thing that I would want to do is start at the acute angle itself and identify my sides. It looks like that's going to be the opposite side. I know that the adjacent side is right next to it, and then opposite the box is always the hypotenuse. Take a look at the picture. There's nothing actually identified on the hypotenuse, so we're not going to use that bit of information. So with opposite and adjacent, that sounds like tangent. So we're going to do tangent of the acute angle, which is 46 degrees, is equal to the opposite side, or the rise, over the adjacent side, also identified as the run. Okay, from here we're going to have to cross multiply to be able to solve for x. This is going to be x times tangent of 46 is equal to 23. All right, let's get rid of that multiplication by dividing on both sides. I know that tangent of 46 divided by tangent of 46 simplifies and cancels. The exact answer for x is going to be 23 divided by tan of 46 degrees. And then to get the approximate, we're just going to go ahead and type this right into our calculator. So it's going to be 23 divided by tan 46 is going to give us 22.2108. So those are my exact answers and my approximate answers. Okay, see if you can set up the equation for question number 2 and then come back and check your setup. Okay, so it looks like we do have tangent again, so opposite over adjacent. We are looking for the angle this time though. So remember, we're going to have to do the inverse of the tangent ratio, which is going to be inverse tangent. And that's going to be applied to both sides of the equation. So inverse tangent of the left-hand side and inverse tangent of the right-hand side. And from here, the inverse tangent and tangent cancel. So it looks like the exact answer for the angle is going to be the inverse tangent of 17/9. And then from here, we type it into our calculator and get the approximation for theta. Looks like that's going to give us 62.1027 degrees. So we have our exact and our approximate. Hey, why don't you see if you can do 3 all the way through and then come back and check your work. Okay, so I identified my sides. Figure out what the ratio is with opposite and adjacent. It is going to be tangent. So we do tangent of the acute angle 29 is equal to x over 34. Cross multiply to get the x by itself. You don't have to do any division here. And then go ahead and type this directly into the calculator. So a little bit of practice on tangent and inverse tangent. And moving on to the next slide. Question number 4, 5, and 6, very similar to each other. So I'm going to talk through 4 and go through and show it, and then my recommendations, kind of the same process that we did on the previous slides. All right, so if we take a look at this one, I'm going to start at the acute angle 44, and I'm going to identify my sides. There's my opposite side, the adjacent side, and then opposite the box is going to be the hypotenuse. We have nothing identified on the adjacent side, so we're not going to use it. So we're thinking of opposite and hypotenuse. Well, that's going to give me sine. So sine of the acute angle is going to be the opposite side length, which is y, over the hypotenuse length, which is 15. Now that we have it set up, solve for y. So we're going to cross multiply. Looks like we're not going to have to divide, so that's our exact answer. And then we'll go ahead and type this in and see what we get. Looks like we're going to get 10.4198. So we have our exact and our approximate answers. Always doing a quick check to make sure that the answer actually makes sense. So the y was a leg of the triangle, so we know it's going to have to be smaller than the hypotenuse, which it is. So it seems reasonable. All right, why don't you see if you can set up the ratio for question number 5, then come back and check it. Okay, so it looks like we have opposite and hypotenuse again, so that's going to be our sine ratio, but we don't know what the angle is this time, so we're going to do sine of theta is equal to 51/72. In order to get the sine ratio to disappear, we're going to have to do the inverse of that. And we are going to do sine inverse on both sides. So we'll do sine inverse on the right-hand side. That's going to force the sine and the inverse sine to cancel. So that's going to give us theta. So the exact value for theta is going to be sine inverse of 51/72. Type that into the calculator. It looks like we're going to get approximately 45 degrees. So 45.0994 degrees. Okay, there's our exact and our approximate answer. All right, why don't you see if you can do 6 in its entirety and then come back and check your work. Okay, and that continues and finishes question number 6 for us. So double check your work. And let's move on to the next slide. So since we've done a lot of practice with 1 through 6 on this, my recommendation is to see if you can complete all of question 7, come back and check your answer, then pause the video again, see if you can complete all of question 8, come back and check your answer, and then do the exact same thing with question number 9. Okay, so double check your work against mine for question number 7, and then pause the video and see if you can complete 8 all the way through, and come back and check your work. Okay, so hopefully you did well with question number 8, and then see if you can move on to question number 9 and get that one completed as well. Okay, and now that's the completion of question number 9. Now, I know on first glance, the answer to number 9 looks a little strange, but really look at the picture. We are talking about an 83-degree angle. An 83-degree angle is huge. So opposite the 83 is going to be a very, very, very large side. Now, it still has to be smaller than the hypotenuse, which is 7. Now, if 83 is the angle inside, then the only other angle that we don't know is going to be a 7-degree angle. 7 degrees is considerably smaller than 83 degrees, which means the side length for x, so opposite the 7, is actually going to be pretty small as well. So I know it looks a little strange, but it is technically accurate. Okay, let's talk about some word problems then. All right, so we've got a lighthouse built at sea is 150 feet high. All right, so I'm going to start trying to build a picture. So there's my lighthouse. I know that it's 150 feet. From its top, the angle of depression of a buoy is 25 degrees. Okay, angle of depression. So let's go to the top of this thing, put the line of sight. Go ahead and erase little pieces of it so I know that's the line of sight. And the angle of depression is 25 degrees. So I would say from the line of sight down, the angle of depression, that's going to be 25 degrees. Find the distance from the buoy to the foot of the lighthouse. All right. So if we put in that distance, I know that right here is the lighthouse, and I know down here is the buoy. I'm trying to figure out how far apart they are. So I'm going to call that distance x. And when we're talking about height of an object, we do think about it as perpendicular to the base. So I think we need to be able to figure out what the x is. Okay, so let's go back a little bit. Something we haven't necessarily talked about in any of the videos, but Your line of sight itself and the ground are seen as two parallel sides. So I would say that across the top here, line of sight would be parallel to the ground. When that happens, this angle of depression, 25 degrees, is alternate interior to that angle that I just highlighted in the bottom. So this is also 25 degrees because of alternate interior angles. Okay, now take a look at the triangle. See if you can set up what the ratio should be for solving for x. So we do have is the ratio comparison of the opposite and the adjacent, or the rise and the run if you want to think about it that way. So this is definitely going to be our tangent ratio. So tangent of the acute angle, 25, is equal to opposite over adjacent. All right, let's go ahead and solve this. So we're going to cross multiply. And then we're going to end up dividing to get the x by itself. So let's divide by tan 25 on both sides. We know that tan 25 divided by itself is going to be 0. Excuse me, whoa, that's going to be 1. So this is going to give us 150 divided by tan 25. And we're going to go ahead and type that in and see what we get. So it looks like x, or the distance the buoy is from the base of the lighthouse, is going to be approximately 321.6760. And let's see, feet. So that's our answer to this question. Okay, last problem. Take a look at question number 11. See if you can set up the picture. So pause it now, read through the question, see if you can set up the picture, and then come back and check your picture against mine. Okay, so here's the picture. Putting measurements in where they belong, we want to find the height of the bridge, so the entirety. It looks like we're going to have to find the vertical distance first from the line of sight. So if I do that, let's go ahead and color code that as y. That's only going to be there. So to see if you can solve for y, so if you want to try it now, pause. I am going to go ahead and talk through it though, so if you want to follow along. Okay, so that's going to give me tangent, using my ratio, I have opposite and adjacent, of 35 is going to be equal to y divided by 100. Okay, let's solve for y. So cross multiply. That's the exact value for y. Let's type it in and see what we get. So that's going to give us approximately 70.0207. But remember, that's not the height of this thing. If we want to talk about the bridge itself, the bridge is going to be that y that we found, in addition to the 1.45 meters than it is above the ground. So we're going to take our 70 answer and we're going to add 1.45 to it. And that's going to give us 71.4707. And the units on this was meters. So the 71.4707 is going to be our answer.